Good morning. This is a video demonstration of homework 3 for Csci 572 information retrieval for team number 12. In homework 1 and 2, we leveraged interesting technologies like Apache Nudge, Tika, Apache Solar, and built a search index using polar datasets from Arcadis, AMD, and NASA. In this homework, we aim to visualize our search results using technologies such as Banana, Facet View, D3.js so that we can answer some challenging questions which have spatial and temporal aspects in them. So let us start with our first technology, which is Banana. So the Banana project is an open source browser-based analytics project. It provides us a search dashboard which interacts directly with our Solar index and gives a nice structured view of the results in different panels as we can see here. So let us run a search query. Say we want to find out what are the trends in oil, iron and other minerals in our dataset. So let us look at the panels one by one. The time picker panel is showing us what is the overall time range of the data in our polar data set. The hits panel is showing us how many hits we have got for this query, which is 568. The histogram panel, this is showing us a nice temporal distribution of the hits which we have got for our query. So every time range is 2 hours in duration. So here we can see that in the duration between 2200 and 0000 we had a lot of peaks, so there is a lot of data corresponding to this interval. Similarly, over this interval we have a number of regions which have hardly any data, so this has a comparatively sparse temporal distribution. Now let us see some spatial distribution panels. So coming to the world map panel, this panel is showing us a geospatial distribution of our search results. So we see that for United States of America we have got about 500 hits. For the country of Belarus we have about 500 hits. For Iceland we have about 500 hits. So this spatial distribution is very useful for making inferences on which regions have a higher or lower concentration. Coming to the tag cloud panel, this is showing us which are the top keywords in our search documents. These keywords correspond to the top TF-IDF values. So we see that we have keywords such as data, site, etc. in our search results. Coming to the pie chart panel, the pie chart panel is showing us which were the top keywords in the titles of our search results. So here we see that most of our search results had the word global, change, directory in their master in their titles. Coming to the last panel, this is the table panel which is giving us the top 50 search results which we have got. Let us refine the search results using this filter over here. Let us say we select URL, title and content. So immediately we see that we get a more structured view of the output. So for each URL we see what is the title of that URL and what are the first few words in the content. So let us run one more query. Say we want to know more about climate changes which have taken place. So immediately we see that the number in the hits panel goes up by a huge factor, which means we have a lot of references to climate change, and the histogram distribution has gotten much denser, and the spatial distribution is also much denser. We have about 10,000 hits for United States, and we have about a lot of hits for India, which is about again 10,000. So that's it about Banana. Let us see the next technology which we have used for visualization, which is Facet View. Facet View is a pure JavaScript front-end for Solar search indices. It is used for performing faceting on our search results. So let us say we enter a search query such as ice. So immediately we see a very nice structured output where we see URLs. Now, Facet View also searches for images if there are any in our search results and shows them over here first. And over here is the main feature of Facet View, which is faceting. So for faceting, we have selected two fields, which is timestamp and title. So as we saw in our banana dashboard that our data set is spread over a time duration of 4 hours. So we have divided our time range in intervals of 15 minutes. So here we see for each 15-minute duration, what were the number of hits which our search index gave. So let us apply a number of facets and see what interesting results we get. So immediately we see that for this particular time interval, we get the results only pertaining to that interval, which is these two results. Let us apply one more filter in the title field. Say we apply the master keyword and the Antarctic keyword. So this immediately gives us results which are pertaining to the GCMD directory, and we see that the results which were about the other keywords in the title have automatically been filtered out. So that's it about facet view. Now let's proceed to the third technology which we have used for visualizing our results, which is the D3.js technology. So the D3.js is a visualization technology which creates graphic visualizations of the input data. These visualizations can be used to make logical inferences and answer challenging questions with minimum user interaction. So we have performed a D3.js visualization for these three search queries. So let us see the visualizations for our first query, which is oil and iron ore and minerals. So this is the map D3 visualization. As we can see, it is showing us a nice spatial distribution of regions which have oil and mineral resources. If we zoom in to the map, we see a more informative visualization, which is which states in the USA have oil and mineral resources, such as Texas or California. So we show this in a nice tooltip where we show the latitude and the longitude. Also coming more towards the east, we see Iceland has also oil and mineral resources. So this data was basically received using NER tagging, and we see these results. So let's see one more D3.js visualization for this query, which is the rotating cluster. So as you can see, this is again a nice visualization. This visualization has been obtained after running the PageRank algorithm on the query. We have visualized the top documents according to the score which we got in PageRank, and this query shows us the most relevant documents out of the 4,000 documents which we had in our Solar index. So this is called a rotating cluster. Now let's look at the next query, which is climate change. Here we show two D3.js visualizations, which is the bar and pie plot. So let's look at that. So this is a bar plot which is showing the extent of sea ice melting as regards to a temporal distribution. So as we can see that the impact of global warming and climate change has caused severe ice melting, and this bar plot is showing how the ice is rapidly melting with each month. So starting from 20, we have reached the level of 45 in just the span of about 2 years. Coming to the next D3.js visualization, this is a bar graph which is showing a spatial distribution of climate changes. It is showing the regions which were most affected by climate change. So we see that United States and Antarctica rank highest, and this is in sync with the results which we saw on banana. So let us see the next visualization, which is the bubble chart visualization. This visualization is showing us the top keywords according to TF-IDF for the query climate change, ice and melt. So we see interesting keywords such as America or California or Arizona, which show spatial based keywords, and also words such as iceberg or melt, which indicate iceberg melting, and polar. So the size of the bubble basically indicates the TF-IDF weight of each keyword. So coming to our sixth visualization, which is based on the query national security interests. This visualization is called circle packing, and it shows us an ontology structure of the strategic areas for the national security interests. So this provides us a nice hierarchical visualization in a graphic sense. So the top level regions are shown at the first level, such as Southern or Antarctic. So if we go into the Southern region, we see that states such as California or Arizona or Pacific, the words which are words such as Pacific or sea, are very relevant to national security interests. Let's say we go into Antarctic. This shows us that land, ocean, ice, these words are also very relevant to the national security interests. This is again a very nice visualization which is showing a hierarchy. So coming to the end of our demonstration, these were the interesting technologies we used to visualize our queries. We were able to get visual answers to many challenging questions which had a temporal or spatial aspect in them. We had a very informative experience in learning these technologies and observing various trends in our data. And we hope you found this demo interesting. Thank you.